All right, what we're going to be doing today are these exercises, and those of you who were with me in Algebra 2 honors last year, namely Nicole and Elizabeth, might remember these specific exercises we did last year. We're going to do the same ones because it's the same sheet you had last year, but we're going to do more than we did last year because I made some of these problems off limits for you last year, but this year we're going to go into them full force. So basically this is an algebra concept leading into inverses of functions. So we're going to solve for y, and how do we solve this one for y here?
6 on both sides.
So I'd go, is that you, Justin? That was Roberto? Okay, so we have 3y equals x plus 6, right? And then divide by 3, right? So we have y equals, and then we have x divided by 3, and then 6 divided by 3, and so that would be our answer, right?
No.
It's not that?
No.
What is
It
it?
should just be y equals.
So you have to switch x and y, and it should be f of x to the negative 1.
Okay, but okay, I see what you're saying, okay? You're working ahead of me a little bit. This is just solve for y.
That's all we're
this is.
doing?
Yeah.
Okay, I got you.
So this is like preliminary to what you're actually thinking about. So you're ahead of the game, so that's good. I appreciate you doing it. But is this correct though?
Wait, so is it x over 3?
It became the 1.
Oh, sorry, I forgot that. Thank you for catching that. Yes, thank you, Elizabeth. I appreciate that. There we go. Good job, Elizabeth. Yay, Elizabeth. Yay, Elizabeth. Okay. All right. Other questions on that? That was a good catch right there. Okay, let's see here. Well, there it is. My pen momentarily got lost. So go ahead and do this one. Let me take care of classroom duties while you do that. Okay, have you finished this one yet? You finished it? Okay, I'm gonna get, okay. Okay, Chloe says she's finished it, so Chloe, I want you to take me through this. No? So you're not that confident on this? Yeah, okay. Anybody help me out on this one? Okay, go ahead.
Subtract the 1.
So we're going to subtract 1 first. So we got 0.5x equals, oops, I forgot to subtract 1, right? There we go. I got to do this, right? Equals x minus 1. Okay,
0.5y.
It's 0.5, yeah.
0.5y. Okay.
And then you
Divide
divide by 0.5.
by 0.5. Okay. Divide by 0.5. Divide by 0.5. So is that good so far? So y equals x divided by 0.5 minus 1 divided by 0.5. Okay, any further simplification we can do on this?
Would that be the same thing?
Yeah, why can't you just leave x minus 1?
Okay, that's very good. I'm going to park that over here. So I'm just going to park what Chloe said right over here. So this is I'll call this Chloe's parking. That's your parking lot. All right, so that's Chloe's right there. Okay, but can we simplify this any further here?
Could it be 1/2 of x? Like 1/2
Yeah,
times x?
Yeah, Justin, what do you say? So Justin's saying, like, Justin, correct me if I'm wrong, you're saying 2x minus 2, is that what you're saying? Is that right?
Oh, I still had the X over 0.5, but I changed the other one to.
Oh, you changed this to 2. Change this, okay. Well, actually, it's going to end up simplifying to this. Okay, let's go, I want to explain something you could have done. And I'm just going to do this on the side over here. What happens if we write this as x? If we recognize that this is 1/2, we could write this as 1/2 y plus 1, and then we subtract,
Oh, and you multiply by the reciprocal.
and then multiply by 2, yeah. So we got 1/2 y equals x minus 1, and then you multiply by 2, and then you have y equals 2x minus 2, okay? And so this is really an example where sometimes it's, some people aren't comfortable, you're not comfortable with fractions sometimes. This is one instance where I think it is helpful. Now, let's go back to Chloe's parking over here. Now, is this, when Chloe writes her answer as y equals x minus 1 over 0.5, is this a correct answer? Yeah, it's a correct answer. It's not completely simplified into slope-intercept form, I would call it, but this actually is technically a correct answer, isn't it? Because she has solved for y, and so it's just something to keep track of, okay? So good job, Chloe, Justin, everybody else, good work. All right, ready to go on to the next one? I have to erase this because we have 6th period coming here. Make sure this is erased too. Okay, we go to number 3. All right.
That's not right.
Okay, it's supposed to be plus 1, is that it?
Yeah.
Yeah.
Yeah, what happened was that this is an actual transcription from the book up here, the graphic, but I mistranscribed it when I put it onto your sheet. So I'm going to go ahead and rewrite this in the form you have, right? So let's go ahead and work this one out. So what's your first step here? Subtract 1, so subtract 1. So we get y squared equals x minus 1, and then what?
Square root.
So square root, I'm just going to continue to write below here, equals, so we square root both sides of our equation, right? So we have y equals square root of x minus 1, okay, is that all?
Should it be I?
Okay, that's another Chloe's parking, okay, question, okay, Chloe, you are just really good today. Chloe's question.
Yeah, I
No, that's good though, because that's Chloe's question about I, right? Imaginary, okay. But is this right here though?
Yes.
No, it's not. What's wrong with this, Nicole? Riley, Justin.
You can't take square root of -1.
Okay, yeah, that's true, but, well, we can, but it's not a real number. But what about this thing right here? There's something that's wrong with it, or incomplete, rather, about this. What is it? Pardon me?
Plus or minus?
Okay, plus or minus. Thank you, Chloe. Plus or minus. Why is it plus or minus, Chloe?
I don't know, I was just guessing.
Okay, she was just guessing, and so she just reached back in there. But this is plus or minus, and what happens is that up till Algebra 2, when you took the square root of something, it was always probably to solve like a Pythagorean theorem problem or something like that, where you didn't have to worry about negative numbers. But here you have to worry about it because, essentially. Now, as far as I goes here, and that's another Chloe question, that has to do with if you just have square root of -1 or square root of a negative number by itself. Like if we had if we had square root of negative 9, that's going to be equal to actually 3i, thank you. I was going to say 9, but actually 3i, good job. Because you'd have to take that square root of negative 1 is equal to I, and then, so, yeah, so, but this is not the same thing here, okay? So you understand that. Good question. All right, let's go ahead and look at number 4.
You know, you can just circle it and then click on the middle and memorize.
Pardon me?
You can just circle it and then.
Oh yeah, I can do that. Thanks for reminding me. So if you can do this one, I think this one is right. So what time does the senior night volleyball start tonight?
We always start at 6.
So you have to 6. You have to wait for the other games to unfold first. Yeah. Okay. Okay, I'm gonna hazard a guess on this one. I think you're gonna get y is equal to plus or minus square root of x plus 6. Is that right? Is that what you got? Yeah, and that's pretty simple, right? Okay, questions on that one? Okay, what I want to spend most of the class time with today is on these next 4. And these are the ones that and I don't know if you have exactly the same, I might have a little bit of a mistranscription here as well. But this is the one you have? Okay. So we're going to solve for y here, and we did this in Algebra 2, the same worksheet, except we skipped over these last year. And why do you think we skipped over these last year?
They were too hard.
Yeah, what it is, the arithmetic was a little more advanced. But does this look like it would be easy to solve for y here? No, Elizabeth's going, no. So what we're going to do is just a strategy when you have a variable in the denominator. In this case, we have a y in the denominator. A strategy is called clear the denominator. Okay, how do we clear out this denominator? How do we get rid of a denominator? Okay, multiply through by that denominator, right? Okay, I think that was Elizabeth who came up with that. So we're going to multiply this whole thing by y plus 3. And when we do that, on the left side, what do we get? We're going to get x times y plus 3. That's on the left side, right? Now on the right side, what do we have left? Y minus 2. Okay? So we've cleared that out. What's the next step going to be here? Just distribute. That was Elizabeth or somebody who said that, right? So we distribute, we get xy plus 3x is equal to y minus 2. Does it look like we're any closer to having solved for y here? No? Okay, but we are, I promise you that. Okay, what's our next strategy going to be here? Subtract 2. Well, we have. Okay, let me tell you what I want to do, and then I want to get everything with a y in it over on the left side, and everything that doesn't have a y in it over to the right side. How do I get everything with a y on it to the left side? Okay, I'm going to subtract y from both sides here, okay? So if we subtract y from both sides, we have xy minus y plus 3x is equal to negative 2. And then subtract 3x from both sides of this here. And so we have that. And then I'm gonna come up here to make room. So we have now xy minus y equals negative 2 minus 3x.
And then what do we divide both sides by x?
Okay, well, if we divide both sides by x, what's happened is we would divide that, but then we'd have to divide this by x too.
So then add 2.
Okay? Any idea? Okay, if we add 2, that's going to bring the 2 back over here. We want this 2 over here on this side where it is. Minus x? No. What's a strategy? Anybody can think?
Multiply by yx.
Okay.
Cancel it.
Let me put it to you this way. What'd you say? Multiply everything by x? Well, that's not, we are kind of cleared up, okay? Between these two terms on the left is there a common factor? The common factor is y, okay? And so y times what equals xy? X and y times what equals negative y? Negative 1. So we have, then what? And we're trying to get y by itself, so what are we going to do next here? What is this x minus 1 doing to this y?
Divide by x minus 1.
Yeah, so Justin makes a suggestion. Okay, this is Justin's suggestion right here, okay? So if we do this, what happens? We have y is equal to negative 2 minus 3x over x minus 1. Now if we solve for y, yeah, we have. Okay, so that would be our answer. Okay? And what I want you to do is go to problem 6. Is this what you have for your problem 6?
Yeah.
If you can go ahead and do problem 6 here, and do that kind of as independent practice. Can you do that? Can you do problem 6 by yourself here? Then I'll go show you.
Yeah, I'm trying.
You're working on it? Good. Okay, Riley, did you finish with this? Not quite. It looks like everybody else finished except Riley.
Oh, yeah.
All right. So let's go ahead and, what was the first thing you did? So if we did that, we got x times y plus 2 equals 3y minus 1, okay? And then if you distribute here, you get xy plus 2x is equal to 3y minus 1. Is that okay so far? Now, I'm going through this pretty fast, so correct me if I misstep here.
And minus 1.
So if we do that, we're going to get xy minus 3y plus 2x equals negative 1. And then what?
You add the 2x.
Subtract 2x. So we have xy minus 3y equals negative 1 minus 2x. Is that right? And then what?
Divide by x.
So I'm going to go up here. We're going to say y times x minus 3, is that right?
Yes.
Equals negative 1 minus 2x. And then,
Divide by x minus 3.
and then we have y is equal to negative 1 minus 2x over x minus 3. Does that look about right?
Yeah.
And did I make any mistakes here?
No.
Okay, you guys helped me with it too, so that's good. All right, well, good. Well, if you look at numbers 7 and 8, they're sort of more like more work along the same lines. So if you could look at, actually, here's what I want to do. I want you to do those later, but I want to just go ahead to 9 and 10 quickly. And we'll let you guys do 7 and 8. I just want to do that. So I'm kind of temporarily skipping these and going to 9 and 10, just kind of for class continuity's sake. And so if we look at x equals square root of quantity y plus 3 and y is greater than or equal to negative 3, what do you notice about that problem? Does anything look weird about that?
There's a comma.
The comma, right? So this part, does this part kind of take you aback a little bit? Okay. Do you know how we got this y is greater than or equal to negative 3? Anybody have an idea on that? You took college algebra. Nicole, you might know. How did we get that? And it has to do with something we did actually touch on earlier this year, briefly. Any ideas? Justin, you have an idea on this one? It might have been before you came into class, Justin, actually. Yes? Yeah. No, I want you to wait just a second, Chloe, just a second before you go. Okay, what it is, can you take the square root of a negative number? No, you can't. So, what do we know about this y plus 3? What do we know that it has to be? We know it has to be greater than or equal to 0, right? Does that make sense? And then if we solve for y, what do we get? Y is greater than or equal to negative 3. Okay, so that's where this thing came from. So basically, it's saying it's a condition, so it's not the answer. Then you work out this part here. So let's go work out. So now that's where that came from. Does that make sense?
So it serves no purpose.
Well, it does, because it tells you what the
Yeah, but like, I mean,
limitations
like, we're
on
not gonna
y
do anything
can be.
with
So
it.
yeah, you don't. This states a condition, a boundary condition of this problem that only applies to y is greater than or equal to negative 3. So now what do we have? We have x is equal to square root of y plus 3, and now what do we do for this one? That we've come to this point. Square, okay, Robert says square, right? So if we square the right side, what do we have to do? Square the left side. So now we have x squared is equal to y plus 3. And then what? Subtract 3. So now we have y is equal to x squared minus 3. Okay? Yeah. So I want you to do number 10, which is similar.
I think we need to go to the bathroom. Can I go after her?
So what I want you to do is I want you to do number 10 and then circle back and do 7 and 8. Can you do that? Okay. And so really that should cover us on our